How did we get here? How did this all get started? Well, the story goes back to 2017 when the market for Wi-Fi mesh was highly fragmented. There were 20 or more different protocols in the market. None of them compatible, and it was just a mess. So in 2018, we started an effort to bring some order into the market, to standardize on a common protocol. So those same companies that were producing proprietary products were brought together to standardize a common protocol, much the same way that Purple works today. And this ended up in the Wi-Fi Alliance as it's called EasyMesh, and it's a multi-vendor protocol that's interoperable, and we'll demonstrate that here later. So that was 2018. In 2019, it just led to multiple independent proprietary implementations of the standard protocol. So if you look at this situation, it didn't do everything properly because we had all these different vendors reproducing the identical non-differentiating protocol. So this is wasteful in effort, but also it makes it difficult to get interoperability if you want to do supersets of the standard. So in 2020, we started the open source prplMesh effort, and this was to produce a common stack that would be portable to RDK, portable to Purple OS, or any Linux-based router operating system. So it's important to note that this is the prplMesh stack is not only compliant with the open industry standard, it's also a superset. And we can get away with a superset because it's a common code base, and so devices based on prplMesh code base can interoperate even with the superset functions. So this is how we got to where we are today. Let me bring this up to date to current time. I'm happy to report that prplMesh has a handful of deployments already in the field. The first two of which come from Sagemcom, who is here today with the demo stand. They were the first to go public with their prplMesh deployments last year, and also their first with an EasyMesh Release 4 certification on top of the prplMesh stack. So this is all good news for the deployability of Purple. And you can see we made two promises. In 2018, we promised that the standard would be multi-vendor interoperable. And in 2020, we promised that the prplMesh stack would be portable to RDK and other operating systems. And I'm happy to report today that we made good on both promises. If you go around and look at the demos we have here, you'll see that we've accomplished multi-vendor interop. In particular, we have prplMesh stack running on 3 different OSs, and the EasyMesh protocol, in fact, running on 6 different operating systems. So we made good on that promise. prplMesh can control retail EasyMesh extenders. So we have 3 different retail EasyMesh extenders: CommScope, Netgear, and NetGem. So that's also good for interop. There are 2 cloud controllers capable of controlling prplMesh agents from AirTies and DZS. Their demos are here. And we have other vendors as well participating: Soft at Home, Cable Labs, Sagemcom, Minim, and RDKB, in fact. Quick background on what EasyMesh does. This is essentially a distribution system. Its job is to distribute the WAN access to all the corners of the home. And EasyMesh protocol is a way to optimize the distribution links, the backhaul links in purple and the front haul links in green. And you can see that each one of the extender APs has a sphere of coverage. And by overlapping those 4 spheres, these different agents are able to communicate wirelessly. If there were a gap between two spheres of coverage, you would want to or need to place an extender in that gap, or else rely on a wired backhaul, Ethernet, G.hn, MoCA, something like this. The good news is that prplMesh supports all of those things. So wired backhaul, wireless backhaul, all the optimizations, and in fact, Frederik's been hard at work producing a demo of just that. A quick snapshot of what the stack looks like. We won't go into all the details here because we want to get to all the other working groups, but it centers around two components. There's a prplMesh controller and a prplMesh agent. The code is buildable either as a controller only and it's buildable as an agent only for a low-cost extender, or you can build the stack as both a controller and an agent for a fully featured gateway solution. And you can see there are some additional add-ons, right? Decision-making algorithms can go on top, Wi-Fi Alliance, data elements for remote management, and optional prpl packages, and even a place for innovative features on top. So this morning you heard discussions about Wi-Fi sensing, this kind of thing. We could easily put a prpl API to expose the Wi-Fi sensing information up through the northbound API, through the high-level API, and make it and expose it to applications. The SoC vendors, they plug in through the low-level API and whenever possible through kernel standards. And it's important to point out that in the northbound API and in the management aspect, we're collaborating with the Broadband Forum and their open broadband projects and the Wireless Broadband Alliance, WBA, as well. This is important, again, to tighten the loop between standards development and implementation so that we can move more quickly. Oops. So at this point, I'll turn it over to Frederik.
Yeah, so I will not go into the entire prpLMesh video right now. We did record a whole demo, but you are welcome to join our stand, and we can go into some details there. What I can point out here is that we have a number of devices that we support, and that you can also see in the demo over there, and that we can actually demonstrate as you like. So we've got prpLMesh running now on both prpls and RDKB operating systems with various hardware backends, GLINet, Torus Omnia, and several MaxLinear platforms, as well as we are excited to start supporting the new platform from WNC, as well as in the future Keon and the new MaxLinear platforms. And yeah, another thing that you can see here is our interoperability and compatibility. So in the demo, we connect not only to prplMesh on various different hardware targets and also prplMesh on RDKB, but you can also see us connecting in a network the different EasyMesh implementation. This one provided to us by CommScope, the RS device. And another demo that we have running on the site is a demo with the AirTies, open source RDKB controller, and you can see prplMesh onboards perfectly to that controller. We should also be compatible with the AirTies cloud controller, but unfortunately we had a few hiccups with setting it up, so we can't demo that today. Yeah, I think that's it for this slide.
Okay. You want to point out the data model and the cable labs topology graph?
You are perfectly correct, indeed. So in terms of data models, indeed, as you can see in the screenshot, and as we can also show in the demo, we are this UI is made possible by our northbound API, which we have developed in collaboration with the Broadband Forum, the OBMAP subgroup. So we are implementing the entire data model, data elements tree, as well as some extra data models as well that we have developed in close collaboration with them. So that's definitely, it's a very extensive API and fully open, and we are collaborating to extend the data model where necessary. And,
so we've put the link to the YouTube video of the demo, and you can see this network constructed from scratch, and you can see this topology graph evolve in real time as the network is constructed.
Yeah, thank you, David. Yeah, just a word about our objectives. At prplMesh, at Purple Foundation, we like to be a bit ambitious, and so for prplMesh, we say we want to be the only, the reference, the only EasyMesh implementation that people will ever need to put on their boxes. So because and to that end, what we want to do is be everything that people need. We need to be certifiable. What that means is that's something that we take very seriously. So we continuously test prplMesh with the latest version of the Wi-Fi Alliance testbeds for EasyMesh. So we have the full EasyMesh Release 4 testbed at one of our sites, and every day automated tests are run on that testbed to verify our compliance with the EasyMesh standards. And we do all of this work to make sure that you don't have to. Operators that deploy prplMesh, they can be sure that prplMesh is compliant with the standard, and that it will be very easy to get that approval from the Wi-Fi Alliance and that standards compliant sticker. prplMesh is also very configurable through the user interface, that the Novotel API that we already discussed. And whenever possible, we comply with existing standards, and where we find that an existing standard is inadequate, we collaborate with whichever instance is responsible to extend the standards and make sure that everything we need is not just possible, but is fully standard and available for everyone to use and inspect. So whether that is a Linux kernel interface or a Novotel API interface or another low-level interface, whatever standards are applicable. And finally, we invest a lot in the stability and deployability of prplMesh as well. Because nobody wants to take a stack that you have to spend multiple months to stabilize before you can do anything with it. So that's also very important to us. We want prplMesh to be directly usable, plug and play as much as we can. So the scope also includes the general Wi-Fi network management. So it should also work for you, even if you're not very interested in Wi-Fi mesh, just to manage your Wi-Fi for a single AP, and just to be more convenient network management, including through remote management, if that is your preferred operating model. All right, so yeah, what we've done so far, we have demonstrated full EasyMesh Release 1 and Release 2 compliance using our test setups, both in agent and controller roles. So this was a very tough effort to crack. We've had many calls with the Wi-Fi Alliance to verify technical points with their test beds, but we finally got there. So yeah, congratulations to our team as well, some of whom are here today. And we have been able to start a very successful relationship with the Broadband Forum as well. So we have our Novotel API that we have co-developed with them, and that is very extensive, very usable. You can see the effects in the demo that we have running over there, as well as some of the other demos like the one from DZS, for instance, is also demonstrating the results of our Norvotel API that we've co-developed with them. And we've set up a very solid testing and CI regime. We have very high standards for code contributions, and I think that shows in the code quality that we have. And especially we've gathered a very strong community. We have a lot of different companies and different individuals coming together to help make prpplMesh a reality. That's the most important part, I think. So going forward, we are now working on EasyMesh Release 4 and Release 5 support. What we've done so far is catch up to the state of the art, and now we want to push it and become a technology leader. We are implementing the latest technologies that are part of that standard, including I think we can mention it. We are our collaboration with Cable Labs for virtual BSS,
Yes.
Which has the potential to become a game changer for Wi-Fi. And then, hardware support is also big on the list. In theory, of course, any software development, we strive to be as portable as we can be, but this is a bit difficult due to because prpplMesh tests wireless drivers like nothing else. So we really need everything we can from it. Of course, we want standardization also on the driver level. So we have support for some chipsets through standard NL8 to 11 kernel drivers for Linux, and for other targets we still have custom proprietary drivers that we use, but we are engaging with hardware vendors and driving that standardization as well. And we will continue to do that going forward. And then the reference algorithms, so prpplMesh so far is not really doing anything in particularly clever with the network, but we intend to implement a few algorithms as well to be able to smartly steer agents and steer stations to optimize the network. That will also be very interesting. One of the things also that we've noticed so far is we've done a lot of testing along in certification testbeds, and we've done a lot of testing of individual pieces of prpplMesh. But then when we prepare for this demo, for instance, we find that we still hit a lot of cases that were not covered by those tests. So we're going to focus more on testing how prpplMesh works in real use cases going forward. And finally, also we are also engaging with the high-level API working group to make sure that all of this is manageable remotely through USB as well. All right. So this is our roadmap in some more detail. So I'm not going to bore you with all of it, just a few key aspects here. So we have, the next thing on the list here for support is our version 3.2, which will bring us the second milestone of the soft at home acceleration planned components. So this will bring with it multi-VAP support, station statistic histograms, a lot of other things. And from the community side, we finished our work on data elements release 2. So you'll also be seeing that one. And we started our work on backhaul management as well. And going forward, by the end of the year, we will also have tri-band support, so 6 GHz support, and other Wi-Fi 6 features, and support for new hardware targets. Finally, we will finalize backhaul management and QoS topics, and finalize also EasyMesh Release 4 and Release 5 support going forward. And yeah, that's
Okay.
I think that's everything.
That's good. Thank you, Frederik.